which has its C-axis, optical axis along the direction interface. And here air, and here is the crystal. Then according to the normal surface, if the C-axis is along this direction, then this means that we have the normal surface like this. This is an example of the positive uniaxial crystal because the ellipsoid is larger than the sphere. Then, if I also plot the normal surface for light propagating in air, I have this sphere. So, if the incident light has the wave vector along this direction, K0, then I can plot this K0 gives us the tangential component of this length. Then I choose this length and plot a vertical line. This vertical line intersects with the inner shell, the sphere, and the outer shell, the ellipsoid, at this point and this point. Then I can connect the origin to this point and from origin to this point. Then these two new K vector represent the propagation wave vector inside the crystal. Okay? If I want to know the energy propagation direction, I have to find the direction perpendicular to the normal surface. Okay, so we get two possible propagation direction of the reflected lights. Okay. Now I can change this situation a little bit. For example, I have the C-axis along this direction. Then say, for example, I have a C-axis along this direction. Then the normal surface may become this shape. 对，就是你等于是把这个，我们现在是一颗球，一颗椭球。 对不对？我们比如说我有一颗球，一个椭球，这是光轴嘛？光轴，我现在是讲 uniaxial crystal，C axis。 我转来转去，好，就是说我切这个晶体的时候，我可以这样切，可以这样切，可以这样切，我可以不同的切法啊。那这种切法的话是光轴跟这个面平行。但我如果不这样切呢？我如果切成斜的呢？如果切成斜的会怎么样啊？那切成斜的其实很有趣，就是说，我即使我入射光是正向的。 Suppose I have an incident wave normal to the intersurface. So I plot this line because the tangential component of k vector now becomes 0. And I got this point and this point. Then the direction normal to the sphere is along this direction. And the direction normal to the outer shell, the ellipsoid, is along this direction. Okay? So I can have one incident, normal incident beam corresponding to two possible refractive beams. Okay, so how to understand this? We can understand this phenomenon in another way. For example, I have this crystal having the optic axis along this arbitrary direction. Then I consider a beam of light incident normally, normal to this interface, which means it is propagating along the direction of the normal vector, or in the opposite direction. So now if I consider the incident beam having the polarization along this direction, then this it gives us the O wave or O ray, because now the E vector or D vector is perpendicular to the optic axis, okay, C axis, which means that it penetrates through this block of crystal and does not change its propagation direction. Okay. However, if I consider the E vector, to be along this direction, if I consider E vector to be lying on this blackboard, then remember that at the interface we have the boundary condition to be continued， 就是说这一侧跟这一侧的 D vector 的 normal 分量要连续 ，B vector 也是 normal 分量连续，好，然后呢 ，tangential component 的话是 E vector 跟 H vector 的 tangential component 要连续，好，这个在第一章讲过，好，那现在你看呢，如果是以这个来说，啊。 Continuity of the normal component of dB and the tangential component of EH。好，你看现在我如何用这个 boundary condition 来理解这件事啊？我先看这一个啊，我现在先看这一个。 this E vector and H vector are parallel to the interface. Okay, there is no normal component of them. B and E along this direction, B and H along that direction. B normal is equal to 0 and D normal is equal to 0. So when they penetrate this interface inside this crystal, the normal component of B and D are still 0. Okay? So the D vector inside this crystal is still parallel to the interface, the surface. Okay? So since the direction of the D vector is perpendicular to the optic axis, this is the O ray, O wave, which means the corresponding epsilon to be used for is epsilon O, and the corresponding refracting index is MO. This is just like light propagating inside the isotropic medium. So the behavior is the same, just like penetrating through a block of glass. So we get this beam along the same direction. However, if I now consider the other possibility means that we have the D vector and the E vector along this direction, and we have H vector and the B vector along the direction normal to the black hole. Then since now, although in this case we still have B normal equal to 0. So inside this crystal, I get the D vector along this direction. However, this D vector have two possible components. This is the D vector inside the crystal. One component of the D vector is along the C axis. The other component is along the plane that perpendicular to the C axis. Since this direction and this direction correspond to different reference epsilon, okay? Along this direction we have epsilon E, and along this direction we have epsilon O. So the E vector change its direction. The direction might be changed to this direction. However, this crystal has no anisotropic property related to the H and B. So the H and B are still along this direction, which means they are still perpendicular to this black ball. So E cross H. So E cross H corresponds to a pointing vector along this direction. Although the K vector might be along different direction. So for this case, a beam of light, unpolarized beam of light, penetrate through this crystal, we get two possible beams. This is the O ray, and here this is the E ray. Okay? Because an unpolarized light have one component has some unpolarized light means that some photons have their polarization to be along the direction perpendicular to the black hole, and some photons have their polarizations lying on this black hole. So for the polarization perpendicular to the black hole, they correspond to the so-called O ray. The O ray can penetrate through this block of crystal directly. And for those photons having polarization lying on this black hole, they correspond to the so-called D ray. And D ray, the D vector can be can have projection along the direction parallel to the C-axis and the components perpendicular to the C-axis. So since along these two directions we have two different permittivity components, so we get an E vector having the direction different from the D vector. So since energy propagation is along the direction of a pointing vector, so if H does not change direction, and the direction of E are changed, then the direction of energy propagation must be changed. Okay. So for the E ray, it changes into this direction, and when penetrate through this, the second interface, it changes back to the original propagation direction. So we get two possible beams.
好，所以你们可以看到那个晶体的某些照片会有这种现象啊，就是它会有这个 O ray啊、E ray啊分成这样，其实就是光轴是斜的啊，你可以去这样用 boundary condition 去看，或者你用 normal surface 去看啊。So you can understand this phenomenon by considering the boundary condition of DBEH, or you can use the normal surface to predict the energy propagation direction. 好，所以这个是目前为止你们学到这个东西可以这样用。
Now I want to tell you more complicated phenomena happening in biaxial crystal, means conic refraction. Now I introduce you the phenomenon called conic refraction. Conical refraction. This phenomenon can only happen in biaxial crystal. For uniaxial crystal, we will not be able to have conical refraction. Now, let me explain what is conic refraction. First, let us consider the three possible planes. We have already introduced you that the normal surface for biaxial crystals intersect with these three coordinate planes and having this shape. Here, this is the Kx, Ky plane. In the Kx, Ky plane, we have this. This is Nz omega over C. Nz omega over C. And here, the major axis, the length of major axis is Ny omega over C, and the minor axis is Nx omega over C. Okay, so along this direction, the polarization is along the Z-axis. Since we assume that Nx is smaller than Ny and smaller than Nz, the polarization along the Z-axis is a fixed direction. So for this fixed direction, the refracting index is nothing but Nz. So we get a circle has the radius equal to Nz omega over C. And if the polarization is not along the Z direction, but lying on the XY plane, then different propagation direction will give us different refractive index. So if the propagation direction is along the X direction and the polarization is lying on the XY plane, then this means that the polarization is along the Y direction. So the Y direction gives us refracting index equal to Ny. So we get Kx equal to Ny omega over C. So if I consider the propagation along the Y direction and the polarization along the X direction, we get Ky equal to Nx omega over C. Okay? So similarly, for the KY, KZ plan, KY, KZ. The radius of this sphere, of this circle, is nx omega over c. And this is nz omega over c. And this minor axis is ny omega over c. Okay, the reason is just like what I have discussed for the kx, ky case. Then finally, for the kx, kz plan, now we consider the kx, kz plan. Kx, kz plan. We have a circle. Its radius is equal to ny omega over c. This circle has the radius equal to ny omega over c. And we have an ellipse. Its major axis is nz omega over c, and its minor axis is nx omega over c. And the radius of this circle is ny omega over c, the radius of this circle. And we know that here we have two intersection points, 交叉点 along this direction and the other along this direction. These two directions called optical axis. So for biaxial crystal, we have two optical axes. Here, this is the optic axis. Here, this is also the optic axis. So if we have this order of these three reference refracting indices, then the optic axis must be lying on the kx, kz plan. If I change the order to say this order, the optic axis are still lying on the kx, kz plan. Okay. If I change the order of these three reference indices to be nz smaller than nx smaller than ny, then optic axis must be lying on the ky, kz plan. OK， 就是中间的那一个就是圆形。
中间那个就是圆形，剩下的那个就是一个长轴一个短轴。OK， 所以呢，你就可以知道它是在哪一个平面啊，在哪一个平面。So now we have already discussed the general propagation direction about phase and energy. However, if we consider the vicinity very close to the intersection point here, we will encounter some very interesting phenomenon. This very interesting phenomenon called conical refraction. Because when we move to the locations very close to this specific point, the shape of the normal surface becomes a cone. This is a cone. OK， 就说我非常靠近这一点的时候 ，normal surface 看起来像什么样子呢？像一个cone，像一个锥。像一个锥，就是说，想象你是一只蚂蚁，你移动到其他地方都没什么问题，就是跟平常的曲面没什么差别，就是局部来看像一个平面，曲面局部来看，只要不是那种特殊的交叉点，局部来看就像一个平面，叫范围够小，它都像一个平面。可是这一点比较特殊。这一点它是内外曲面的交叉点，这是有一个 vertex， 它有一个交叉点。那这种面呢，它就不是像平常的这些其他地方，只是一个这样的曲面，它是一个cone，它是一个锥。它是一个锥，那这个锥呢，就会产生一个跟锥有关的特殊的现象，这现象就叫做 conical refraction。This specific point is very special because locally the geometric behavior of the normal surface close to this specific point is not like other points on other places of the normal surface. If I choose an arbitrary point at normal surface and the area is small enough, then it looks just like a plan. A little bit bent, but it still looks like a plan. However, if I move to the vicinity, I move to the places very close to this specific point, I see a cone. What is the optical effect of a cone? If we consider a beam of light having its pointing vector
along this direction. This direction. In fact, a beam of light is not a plane wave. Okay, it includes not only a very specific k, it includes a range of k. So a beam of light corresponds to, say, a range of k. So if the k is located here, we get the normal vector along this direction. If the k is located here, we get the normal vector along this direction. Okay. So finally, for a range of k vector very close to the central k vector, say k0, we consider a beam of light having k belong to the set of k0 plus delta k. And the delta k is much smaller than k0. So we may encounter k located here, k located here, and for this k we have group velocity along this direction. For this k we have group velocity along this direction. So finally, if we collect all possible group velocity, we also get a cone. Okay, this cone is corresponding to all possible group velocity. However, group velocity gives us the direction of beam. Okay, so this means that originally we have a beam just like a solid cylinder. Then after encountering the this very special point, they become a cone of light. 就这光啊，本来是一束实心的一个圆柱，但是呢，如果你让它呢进入到 crystal 时候，遭遇到这样的状况之后，出来的光会变成是一个锥。好，那这一个锥会发生什么状况呢？是这样的。Suppose I have a block of biaxial crystal, and this is the c-axis perpendicular to the interface, which means you rotate this so that k0 vector along the c-axis direction. Then if I send a beam of light here, this beam of light will become a cone. Okay, and when this cone of light penetrates through the second interface and projected on a wall or screen, we get a ring. We get a ring. Okay. So this phenomenon is called conical refraction. Conical refraction. Conical refraction.
this phenomenon can happen only in biaxial crystals. Because only for biaxial crystal we have two optic axes, and these two optic axes locally give us cone structure. 好，就是说只有双轴晶体呢能够出现两个光轴，而这两个光轴呢，这四个点呢，局部来看它都像肚脐。Locally, the structure close to this specific point is just like something just like belly button 肚脐就像肚脐你就想象它好像肚脐形状。然后呢，局部来看它就是光锥就是锥形。那个锥形所造成的后果就是你一束光呢。一束光其实它的 k vector 不是完全一个值，它是在这个附近。然后呢，你附近的时候，你就对应到这个锥上面不同的点，然后每一个点去看它的垂直方向，就是所谓能量传播方向，它是错开的。所以你把这些收集起来，它就变成一个能量的锥能量传播的锥。所以we have the cone of k vector, and we also have the cone of group velocity, and this cone of group velocity give us this phenomenon. 所以这个叫做 conic refraction. So this phenomenon is called conic refraction. Now I do a little bit, do some math to verify the cone structure. We already have k vector written as kx, ky, and kz. Now I define, for the convenience of calculation, I define a new vector called P. P is nx, kx, ny, ky, and nz, kz. So now I want to derive an equation of normal surface, and I want to see locally the behavior close to this specific direction. Remember that we have equation of wave normal written like this: sx squared over n squared minus nx squared plus sy squared over n squared minus ny squared plus sz squared over n squared minus nz squared equal to 1 over n squared. Okay, this is the equation of wave normals. Here S is the 3 component of the S vector. This S vector, this S vector is the small s, not the capital S. Small s means the unit vector along the K vector. Then I use the property that S dot S is equal to 1, which means Sx squared plus Sy squared plus Sz squared equal to 1, and substitute this result into the right hand side. Then I can change this equation into this form. I have already
derived this equation previously. So we have this equation. So according to this equation, if we multiply them by the three factors, n squared minus nx squared, ny squared minus n squared minus ny squared, and n squared minus nz squared, we get plus here we have n squared minus nx squared, n squared minus nz squared, n squared minus nx squared, n squared minus ny squared. Okay, we get this equation, and OK， 我先在这边暂停一下，我们下课10分钟。我们上课之后就从这边去推出这个空的形状。好 ，OK， 我们先下课一下。